Hi, welcome. This is Think for Yourself, an introduction to critical thinking. My name is Mark Thorsby, and we'll be using a workbook for arguments by David Morrow and Anthony Weston. I encourage you to follow along. In this video, we'll be taking a look and continuing our discussion of generalizations. In the previous two videos, we began by taking a look at the notion of what a generalization is, where we articulated the idea that generalization is when one takes characteristics or attributes from individual examples and applies them to an entire category or group. That is, generalizes one aspect to an entire category. This is what a generalization is. Generalizations are an important part of reasoning. There's good generalizations and bad generalizations. All generalizations are inductive, which means they're only probably the case. They're not necessarily the case. And that probability can come true, and sometimes it doesn't pan out. In the previous videos, we looked at, let me zoom in over here, we looked at the importance that when we make a generalized claim, we need to use more than one example to support the claim. The second thing we need to do is we need to make sure that the examples we use are representative. It was in this last video that we discussed the notion of a sample size, and also the notion that the sample size needs to include an appropriate proportional cross-section of the entire category that you're going to be talking about, or that someone's talking about or making in their generalization. In this video, we'll be looking at background rates, and Rule 9 is that background rates may actually be crucial when we evaluate and understand generalized arguments. So let's start off with this question. Well, what exactly do we mean by a background rate? A background rate can refer loosely to the rate at which some event or agent occurs at a particular time or in a particular place and in the absence of certain conditions. Okay? So background rate, first and foremost, concerns the frequency of events that can occur in event cycles. So I have sort of a little example here I pulled from some chart online here. But you can see here they're talking about unemployment rates, and you can see over time the unemployment rates change, right? So whenever we talk about events and we make generalizations that events will occur, it's important that we recognize what's normal in terms of that event's frequency of occurring, right? Frequency refers to how often something will happen, right? And so some things have high frequency and some things have low frequency. But depending on the frequency and depending on whether or not it has a high or a low frequency, that can really make a lot of difference in terms of how we evaluate a generalization or a claim that is or is not accurate and faithful to that background rate. Well, an example you could say is that in the last video we talked about the idea that your sample size has to be representative. In this video, what we're going to be really saying is that when we were talking about events, the frequency of examples the examples of the frequency you give must also be representative. So why does all this matter? Well, a generalization about the probability of an event depends upon examples that are representative of the event's actual chances of occurring. So compare these two examples, and I sort of made these up based upon an example that's given in the book. Imagine someone says this: I got a hole-in-one on the golf course today, therefore I'm an excellent golfer, right? Well, most of us initially are inclined to think, wow, yeah, you are a good golfer if you can get a hole-in-one. But wait a second, now compare it to this argument. When I play golf, I get a hole-in-one I get a hole-in-one at least 6 times per game, therefore I'm an excellent golfer. So in this example, this person got a hole-in-one, but they're also giving us support about the frequency of their hole-in-one, right? They're saying that when they go to play golf, usually they get 6 hole-in-ones per game, which is insane, right? That would mean that they truly are an excellent golfer because pretty much every time they can get it almost or right into the hole, right? But by contrast, it is a probability that if you just sit on the golf course hitting golf balls, eventually you will get a hole-in-one. Just because you got a hole-in-one once does not mean you are an excellent golfer. I say this, I've never got a hole-in-one, but you can imagine that, right? what's the difference here is because we have to look at the background rate of what normally occurs. It's very rare to get a hole-in-one, and so to get one usually means that you're a pretty good golfer, but it can also be chance. But if you're getting lots of hole-in-ones as a golfer, then that means that you're consistently up there at that top tier level, which means that you probably are an excellent golfer. The difference here is that in one example, we have a background rate that's identified, and in the other, we don't know what the ordinary background rate would be, or the background rate for that particular example. Here's another helpful hint. Don't only focus on the probable rate or the frequency of the event occurring, but also on the probable rate or frequency of the event not occurring. A lot of times what can happen when we see generalized arguments is people will talk about the frequency of something occurring that they like, but they won't talk about the frequency of the same thing not occurring. So for instance, think about if someone gives you an argument about astrology, right? Someone says, listen, I read the horoscope, the astrology horoscopes every week, and 9 times out of 10, when I read them, those horoscopes really reflect things that are going on in my life, right? Imagine if someone made that argument to you, right? Their argument is you should believe horoscopes because they frequently represent my experience, right? That's what someone who believes in astrology usually would say. But the problem is that in that case, the astrologist only focuses on the probable rate of that event occurring for one particular example themselves. Where if we look at the probable rate or frequency of the event not occurring, not just for them, but for everyone, what we'll see is that more times than not, astrology actually does not a very good predictor of how people are going to live their lives, right? So if we look at the frequency of the event not happening, if we look at the background rate negatively, a lot of times we'll be able to see the argument in a fuller context. Oops, sorry about that. Trying to move to the next slide. Okay, so you should look to the background rate, and this is just understanding the regularity of the frequency of events that people cite in their arguments, their generalized arguments. So here's an example, and if you're following along the exercises, what you're going to be doing in this section for this rule is you're going to be learning to identify the relevant background rates. So here's an example from page 51. Let's take a look at it. And let's talk a little bit about identifying the relevant background rates. Pardon me. In a recent experiment, some students used a studying technique called retrieval practice essays. After reading a passage, the students wrote down what they remembered from it, without the passage in front of them. And that should say front. A week later, these students answered about 2 out of 3 questions correctly. Therefore, writing retrieval practice essays is a good way to study, right? Okay, so first off, this argument basically is making the generalization that if you do retrieval practice essays, it's a great way to study. The example they give is this recent experiment that they did with these students. Now, most of the time when you'd read this, you'd see it, oh, it's an experiment. Okay, so it sounds more official, but hold on, let's think about it, right? In order to say that this retrieval practice essays technique is a good way or the best way to study, we have to also know about what the normal background rate of answering these questions correctly would be without doing the retrieval practice essays. What if, for instance, we take a look is that students always get 2 out of 3 questions correct, no matter what kind of technique they use. And even worse, imagine, for instance, students who don't study at all get 2 out of 3 questions correctly. If that was the case, if we knew what the background rate was, we could be able to assess whether or not writing retrieval practice essays really is a good way to study. So think about this, for instance, as you're going through your life, at work, at school, wherever, when you're hearing arguments, try to cultivate the habit of asking yourself about, well, what's normal under these conditions? Are these conditions comparable? So this is a good example here of where, since the background rate is left unspoken here, we can't really assess whether or not this is a good generalization or a bad one. We make generalizations all the time, but we need to become aware of their representational aspect, especially when we're talking about frequency of events. And so that's what background rates are all about. Okay? In the next video, we're going to be taking a look at Rule 10. We're going to be looking at statistics and the idea that statistics really need a critical eye. Thank you very much for watching this video. I hope it's helpful, and I look forward to seeing you online.